ahead and get started. Alright, coordinates in a matrix. We can represent points on a coordinate plane using matrices. So the coordinate, the x, is always going to be on the top. It's always going to be on the first row, and the y will be in the bottom row. So the coordinate would just be a 2x1 matrix representing that coordinate, and we would call this a vertex matrix, which is a matrix of all of the coordinates of the vertices of a polygon. And you have, again, one column for each point of the polygon. So whether that's triangles, squares, rectangles, whatever that may be, we can use a vertex matrix to represent those points. Transformations. They are functions that map points of a pre-image onto its image. And again, a reminder that that pre-image is the original figure that we're looking at, and the image is the figure after the transformation. So after we have moved it, rotated it, reflected it, whatever we're going to do to it, that is the image. Translations. Translations, these are just when you take a figure and you physically kind of pick it up and just move it to a different location. You don't change its size, you don't change its shape, you don't change the orientation of the figure, you're just really picking it up and moving it to a different location on the graph. So here, translations is when a figure is moved from one location to another without changing its size, shape, or the orientation. And to use this, we're going to use a matrix. We're going to use matrix addition in a translation matrix to find the coordinates of the image. And that translation matrix, we'll talk about that here in a second with the first example. So they're asking us to find the coordinates of the vertices of the image of quadrilateral QUAD with these vertices. So first we're going to start by writing our vertex matrix. Again, x's are on the top, y's are on the bottom. So for point Q, we would have 2, 3. U would be 5, 2. A is 4, -2. And D is 1, -1. So there's our vertex matrix. Now they're asking us to move it up 4 units to the left and 2 units up. Now to do that, we're going to use matrix addition here. We're going to create a new matrix, again the same dimensions as this one in order for us to do matrix addition. So it has to be a 2x4. So when we create this 2x4, remember the top is the x's, so when we're moving left, that is moving us along the x-axis here. And to the left is going to be negative. So each of these values in the x value should be negative. So we're going to have -4, -4, -4, -4. And the y values, we're moving it up, so it's going to be positive. So it's going to be 2, 2, 2, and 2. So it's the same value for all the x's, same value for all the y's. And all we're going to do is add that to these points, and that'll change the coordinates and really just move this quadrilateral from one position to another. So as we do this matrix addition, we're going to have 2 plus a -4, which is -2. 5 and a -4, which is 1. 4 -4, which is 0. 1 -4, which is -3. And then for the bottom, we're going to have 3 plus 2 is 5. 2 plus 2 is 4, -2 and 2 is 0, and -1 and 2 is 1. And so these are the new coordinates of our quadrilateral here. So we're going to have Q prime, we're going to call -2, 5. U prime would be 1, 4. A prime is going to be 0, 0 at the origin. And D prime will be -3, 1. So those are the new coordinates of our quadrilateral QUAD. now we're going to be looking at some dilations. Dilations are when you either enlarge or reduce the figure's shape. So this isn't changing the direction of the shape, it is really just changing the size of the figure. And in order to do this, we use scalar multiplication to find the coordinates. So if we are cutting it in half, if it's a scale of 1/2, you just multiply it by 1/2. If you're doubling or tripling the size of it, it'd either be a +2 or a +3 that you'd multiply the entire matrix by. So example number 2, we have a triangle JKL with the vertices J, -2, -3, K, -5, 4, and L, 3, 2. We want to find this so the perimeter is half of the original perimeter. All that means is we're changing it by a scale of 1/2. So we're scaling this down. So first let's start by writing our vertex matrix. Again, x is on the top, so we have -2, -3. We have -5, 4. And we have 3, 2. Now for my new coordinates, I'm going to take this, I'm going to multiply the entire thing by 1/2. I'm going to distribute that to every point inside. So for my new coordinates, we're going to have 1/2 times -2 is -1. 1/2 times -3 is -3/2. 1/2 times -5 is -5/2. 1/2 times 4 is 2. 1/2 times 3 is 3/2. And 1/2 times 2 is 1. So J prime would be -1, -3/2. K prime is -5/2 and 2. And L prime is 3/2 and 1. And those are the 3 new coordinates of a triangle that has half the perimeter of the original triangle. Let's move on now and talk about reflections. Reflections, these get a little more complicated only because there are particular matrices that we have to multiply by, and so we will be doing some matrix multiplication for both rotations and reflections. Just a side note here, reflections and rotations, you will not have to memorize these matrices. Okay? When we're multiplying these things, you will not have to memorize which ones go with which. This chart will be given to you along with the rotation chart on your test. I will have a cheat sheet kind of on the front of this test, and so there will be a certain number of things that you will not have to memorize both in this section and some of the subsequent sessions that we're going to be doing. So these are the matrices that you're going to be multiplying by to reflect over the x-axis, y-axis, and then the line y equals x. So it's important to kind of keep these handy as you're doing your homework tomorrow in class, so that you can be multiplying by the correct thing. And do not try to memorize these at first, because make sure you're multiplying by the correct thing. So that's why I say keep these handy. Okay, so we have Q, R, S, T, and U, and we are going to reflect this across the y-axis. So first, let's start by writing our vertex matrix. So we have Q is 1, 3, R is 3, 2, S is 3, -1, T is 1, -2, and U is -1, 1. Now remember, in the last slide on that chart, it says to multiply these on the left. So we're going to take the one that reflects us across the y-axis, which is a -1, 0, 0, 1, and we're going to multiply it on the left-hand side. Because remember, the middle two things have to match. So we have 2x2s for reflections, and those have to match the 2x5 here. So we're going to have the -1, 0, 0, 1. And it's going to go on this side of it. So -1, 0, 0, 1. So let's go ahead and multiply those. And again, we get a 2 by 2 times a 2 by 5 should still give us a 2 by 5. Because we're not eliminating any of these points, we should still have a 2 by 5 at the end. So that all of our points have just been changed. So negative 1 times 1 is negative 1. 3 and 0 is 0. So we just get negative 1. Negative 1 times 3 is negative 3. Plus 0 is negative 3. Negative 3 plus 0 is negative 3. Negative 1 and 0 is negative 1. And positive 1 and 0 is a positive 1. So those are all of our new x coordinates, and now we're going to go through and do all of our y coordinates. So we'll multiply the second row by each column. So we have 0 and 3 is 3. 0 and 2 is 2. 0 and negative 1 is negative 1. 0 and negative 2 is negative 2. And then 0 and 1 is 1. And so this is our new set of coordinates. I'm just going to rewrite these with the prime notation. So we have q prime is negative 1, 3. R prime is negative 3, 2. S prime is negative 3, negative 1. T prime is negative 1, negative 2. And U prime is 1, 1. And so those are the coordinates if we have reflected this over the y-axis. And here's the matrices that we're going to be using to do some rotations. Again, we are not memorizing these matrices. These are things that will be given to you, because I don't want you guys to get confused and messed up over just some of the negatives and positives and where they occur. So you will not be memorizing these things. And again, we're multiplying on the left-hand side so that the 2's in the middle will match. So we have 1 if we are multiplying by 90 degrees, 180 degrees, and then 270 degrees. So let's go ahead and look at an example of this. Example number 4 here, we are rotating this 90 degrees counterclockwise about the origin. And that's what all of these are counterclockwise. So you are moving counterclockwise, and we're doing 90 degrees. So we're using that first one of 0, negative 1, 1, and 0. So I'm going to go ahead and write that one out first. Again, on the left-hand side, so we have 0, negative 1, 1, and 0. And then we'll write out our vertex matrix. 4, 3, 2, 1, and 1, 5. So let's go ahead and multiply. So again, we should get a 2 by 2 and a 2 by 3 will give us a 2 by 3. So we'll have 0 and negative 3 is negative 3. 0 and negative 1 is negative 1. 0 and negative 5 is a negative 5. 4 and 0 is 4. 2 and 0 is 2. And 1 and 0 is 1. So those are our 3 new coordinates. A prime is negative 3, 4. B prime is negative 1, 2. And C prime is negative 5, 1. So again, we can do all of these translations that we've done so far. The translations, the dilations, the reflections, the rotations. All of these can be done without ever graphing the figures. We are able to do all of this just by using some of these matrix operations, starting with the matrix addition, scalar multiplication, and now finally finishing up with our matrix multiplication. Here is that homework assignment that you will be doing tomorrow in class. So this will be what we work on in class. If you have graph paper, go ahead and bring some of that, because I will be having you graphing some of these things so we can graphically see how these are being affected with our matrix operations and things.